right, picking up in section 8.2 where we left off, finding the GCF when we have variables. So in our next one here, we see we have x's and y's, and z's. So we're going to be looking at each of them. So here we have a squared power, a cubed power, and a squared power. So the lowest power is an x squared. So in our GCF, our x squared is going to be part of the GCF. And in other words, every single term we could take an x squared out. Now we investigate the y's. There's a first power, a second power, and a first power. So the lowest power is a first power, so y. We can take a y out of every single term. Now the last one can be a little tricky, the z's. So here we have a z to the first power. There's no z's in here, so don't get mistaken that z to the first power is our lowest, because remember, we could always artificially put a z to the 0 power in each of these. And then what would be the lowest power? The one that we see here or the zeros here? The answer would be, of course, the zeros, which means that z is not a part of our GCF. Our GCF is simply x squared y. And if you check that out, could you divide these by a z and have it come out evenly? Oh no, you couldn't, so that's why. All right, now looking at our next example, we have numbers there too. So now we're going to find a GCF for numbers and a GCF for variables. So number-wise, we go 1 and 2 and 4 and 8. And then 10, we have 1 and 2 and 5 and 10. And then we have 16. Now notice that 16 is negative. Negatives don't normally come into being part of the GCF. There will be a case where we want to take a negative out, but we don't usually consider a negative part of the GCF. So we're just going to ignore that. So we have 1, 2, 4, 8, and 16 here. And now we look for the GCF. So again, the biggest thing that we see in common is a 2. So my GCF is a 2. Remember that GCFs are not actually big numbers. They're just small little pieces, small little cookie crumbles. Now 2 is not all we have because we have variable parts. So we see a second power, and a third power. So the lowest exponent is a 2. So our GCF is a 2x squared. And then to check it out, can I divide this one by 2x squared and have it come out even? Yes. 2x squared here and have it come out even? Yes. Divide here by 2x squared and have it even? Absolutely. So that will be my final answer. All right, so now what we have going on is 3 a little bit more complicated ones. So we're looking at the numbers first. So we look at the 15, and 15 we have 1 and 3 and 5 and 15. And then 20 we have 1 and 2 and 4 and 5 and 10 and 20. And I'm going through these in my head in order to get these, but you're only seeing that I'm listing them out, but I am thinking of those in terms of pairs. And so then we have 1 and 2 and 5 and 10 in the 10. So in common, we have 20 out here, nothing there, 10 here, but not there, 5 there, 5 there, and 5 there. So we have 5s in common. So my GCF over here is going to have a 5 in it, but that's not all, right? Because it's got variable parts in it as well. And then we look at the x's, x squared, x to the 5th, x cubed. So the x squared here is the lowest, so x squared. Then next I go take a look at the y's, cubed, squared, squared. So y squared. And now z's, there's no z's except for in this one, so that means it can't be part of the GCF. And then again, the negative here, ignore it. All right, now we're going to do factoring by using this GCF. So that was our goal in the first place. So factoring using a GCF, what we're going to do is we're going to look at all the terms and we're going to find a GCF. And then we're going to rewrite it as the GCF times a sum of the quotients of the original terms divided by the GCF. So we're just going to practice that in the next examples here. So I've already written a GCF out here, and already written the GCF out here, and already written a factor out here, and we're just going to practice the divide and rewrite part. And so you'll see that in the next video.